or MRTs left, so we had to take a taxi. And we were charged super high that night. So we were very angry, and so we started looking into this question about how we're being charged here in Taipei for the taxi. So we decided to make this research our final project. Okay, here's our agenda. I'm going to talk about a little bit about industry introduction and how to maximize the revenue for taxi drivers. And we take social welfare into consideration, and then we come up with some possible suggestions. So the study aims to research the current fare of the taxi and its comparison with pricing optimization. So we have conducted in order to formulate a fare system which maximizes the total revenue of taxi drivers in Taipei. We have executed several literature and government database survey. So this is our research process. And the current situation is like this. The characteristics of the taxi cab is it's a pay-per-use service. It's very easily accessible, and it's quite comfortable, and it kind of helps solve the parking space problem we have here in Taiwan. So, the current fare system is modeled by the Taxi Association in different cities and supervised by the MOTC, which is the Ministry of Transportation and Communications here in Taiwan. Given that the entry barrier is very low, the fare system is designed to avoid destructive competition among drivers. The fare system is also designed to cover average costs, average operation costs, given the drivers a reasonable profit. Pricing formula is based on the distance traveled, the time rate, and the idle time rate, and the nighttime surcharge. And that explains why we're charged so high late in the night. So, nevertheless, there are still several critical issues that should be managed, and such as information asymmetry and excess supply. You know that we have over 30,000 cabs here in Taipei City, and they have a very high vacancy rate. The current pricing scheme for taxis here in Taipei is like this. There is a flagpole price, which is the initial price here. It's 70 for the first 1.25 kilometers. And the subsequent charge here is 5 per 0.25 kilometers. And the waiting time, or the idle time rate, is 5 for every 100 seconds. And the nighttime surcharge is 20 per ride. We found some key operating statistics shown on the MOTC website. And as you can see, the daily vacancy rate here is around 3.5 hours, which is one third of the daily operating time. In other words, the taxi drivers spend too much time in waiting for passengers, which will lead to other exogenous problems such as air pollution and decreased social welfare. So the key point here is to reduce vacancy rate. Okay, our target market that, given that technology today has very advanced through the last decade, and we target at the traditional way, the cruising taxi. The cruising taxi is that they drive around and picking up customers, and when they are delivering the customers to another stop, they look around for another customer. So they can't be reserved by phone or anything else. So we start maximizing the revenue of the taxi drivers here. The current pricing policy is shown here in the formula, and where is a mixture of time and distance. The X is a mixture of time and distance. Okay, so as constraints are only demand-side problems, we need information on both demand distribution and willingness to pay from the customers. So luckily, we were able to find some demand distribution information on the Taipei City government's website. We can see in this graph that most of the customers' demand are here, which is around the range of 1.5 to 2.5 kilometers, but with a little peak here in the long-distance customers. These customers have an average pay for around 80 to 100. Okay, here's the complete data on the demand distribution as shown in the figure in the previous slide. So another public government report has studied the willingness to pay of customers. The figure here shows the correlation between taxi fare increase and the proportion of customers that are willing to pay for a price increase. And so from the demand distribution table, we were able to calculate an estimated income per travel. So as we can see here in the table, the estimated income per travel actually rises when we increase the price by $5 NT dollars. So here, okay. We graphed our result, and it looks like this. So you can see that there's this tiny increase here with the increase of price. So we achieve a maximum point. But how do we increase this price? In order to find out the answers, we first need to break down the current income mix into fixed, variable, and lead time. Okay, since we cannot control, I'm sorry, I said lead time, I meant idle time. Since we cannot control the idle time income, we're left with two options. One is to raise the initial fixed price, and the other is to increase the price per distance traveled. If we increase the basic or the initial price, it may alter the customer demand. Since the price increase is so apparent, someone might think that, oh, you increase the price, I don't want to take a taxi. But there might be some short distance customers against this price hike, and therefore lead to a dramatic drop in demand here. So this is not a very good option if we want to increase the price. So how can we increase the variable price? Okay, we can increase the meter price, say from $5 to $7 per jump. Okay, but that is not a very smart option because the driver will have a very difficult time giving change to customers, and you will be filled with coins afterwards. So, so we decided to increase the variable price by decreasing the distance per 5 NT dollars. As shown here, we originally, the 5 NT dollars would give us a 0.25 distance, but now it's only a 0.244. So it's a very negligible increase, but it would do a great help if we increase the average variable income by 5. Using this new pricing scheme, we can generate more income, but it can also cause some problems. The potential issues here is the most obvious one is adverse selection. Because the new pricing scheme does not equally increase each customer's paid price, so some might feel unfair and chooses not to take the taxi. While others may take the taxi more often, but they might not be our best customers, best profit-generating customers. Okay, in our previous analysis, we assumed that adverse selection does not take place. But, however, in the real world, we should take adverse selection into consideration. This may lower the respective customer's demand and harm driver's income. Okay. In reality, the Ministry of Transportation and Communication, MOTC, has regulation on taxi. Okay, standing on the viewpoint of the government, it is to maximize social welfare is more important than to maximize the revenue of the taxi drivers. So in this part, we try to develop a simple model which takes social welfare into consideration. Okay, we start off by building a model and then solving question, and then we interpret the model and find out the coefficients. So by definition, social welfare is equal to consumer surplus plus producer surplus, and is calculated by the formula here. Okay, and we also have to formulate a demand curve. Q equals alpha plus beta P plus gamma V, and it's gone, but okay, I will write it down. So note that the alpha is a coefficient here. And the P is the average price per kilometer. And the Q is the kilometers of driving with customers. So you're getting paid. And the V is the kilometers of driving without customers, which are losing money. Okay, alpha, beta, gamma are coefficients that we will have to find out. Okay, and C, also C is the average unit cost of driving 1 kilometer. That is the coefficient. That is a constant estimated by the Taxi Drivers Union and the MLTC. Okay, our objective then is to maximize consumer surplus plus producer surplus here. So we take this the two formulas together and we combine it into this equation. Okay, so to maximize it, we need to take the first order differentiation on V and Q. So that we express Q, V, and P in terms of alpha, beta, gamma, and C. Okay. The taxi driver here has to pay C dollars per kilometers they drive with or without customers in the car. That's the cost of the depreciation and gasoline and others. Okay, so the drivers are losing money when there are no customers. The producer surplus is negative number of C times V, as we have calculated. So the producer surplus is a negative number. So in order to maximize social welfare, taxi drivers require additional financial support, or there will be no longer be any taxi drivers at all. This is an interesting finding, but not too surprising when it comes to social welfare. Every year, our national health insurance system is losing money. But at the government's point of view, social welfare considerations are of first priority, or in other words, they need the votes. But therefore, we have a conclusion here. The optimal price equals C will make drivers profit negative. So to estimate the coefficients, alpha, beta, and gamma, we use some public data or research. And here's what we found out. There are quite a few studies and government reports on these things on the website. Okay, estimating alpha. So alpha is the intercept of the demand curve. And its economical meaning is that if taking a taxi is free, how many kilometers will people use every day? So it must be very, very high. Beta is the coefficient of price. Its mathematical meaning is delta Q over delta P. And the economical meaning is how many kilometers of demand will decrease when price decreases by 1 unit. And the gamma is the delta Q over delta V. And economical meaning is how many kilometers of demand will decrease when V decreases by 1 unit. And as I said before, the C is a constant estimated taxi labor union and MOTC. So here's our finding of the coefficients after we solve the equation. And we replace the alpha, beta, gamma, C into the optimal Q star, V star, P star by equation 7, 8, and 9. Okay, here's what we found out. The optimal price per kilometer is 19.6. And the optimal percentage of available taxi, 就是最适空车率, is 30.23%. And to summarize, in order to maximize the social welfare here, we need a negative producer surplus. So we reach our conclusion here. Okay. Given that a negative producer surplus, it is needed to be financially supported by the government or creating other revenue channels. Okay. So there are some flaws with our model, but the most apparent one is that there might be other demand impacting factors that we didn't consider and should be taken into account for a more complex but more solid model here. So now that we know that the taxi drivers must lose money in order to maximize social welfare, what about possible subsidies the government can give them or the other revenue sources they can get? So there are two main costs for a taxi driver, the car and the fuel. So we start by looking into these two categories as for subsidies. Okay. During driving around the city with the empty car is very expensive. The drivers are struggling to make ends meet. So the MOTC tried to provide subsidy for the taxi drivers. And the taxi drivers receive discounts of around $2 per liter of gasoline, and with a quota of 450 to 550 liters per month. The volume subsidized fluctuates depending on the fuel price at the time, but it's roughly this number. But given that they are always complaining and protesting about these subsidies, I believe that this is not enough for them to run a profitable taxi service. So another type of subsidy is for new cars. Excuse me. In order to realize more social welfare, the government now subsidizes for hybrid vehicles, which runs on both gasoline and electricity. According to the MOTC announcements, the drivers of old taxis will receive a subsidy of 115,000 NT dollars if they renew their previous vehicles to a hybrid one. For additional revenues, the most common source is to provide advertising space. It's very common to see ads on the taxi that drives around and the other buses, the public transportation system. And it's a very easy way to increase a stable income. Okay, we can see a lot of taxi companies apply this model to their taxis. Okay, since taxi are always visible and around the city, 24 hours a day, 7 days a week. So advertisers have a range of options from rear window advertising to full livered vehicle advertising. So there are a lot of other sources like to make advertising more profitable, such as precise marketing. So nowadays, taxi companies often encourage customers to sign up as their members, so you can call for a taxi faster than other non-members. So by recording and analyzing the members' data, they can use these data to arrange the proper ads to fit the target customers. So therefore, charging a higher premium to advertising company agencies. The Taiwan Taxi implemented this advertisement model on their taxi for years, and the numbers speak for themselves. Now the advertising revenue achieved more than 30% of their total revenue. So that is about our presentation. Thank you very much. Any questions?